This video is for Math 116, and this is about the equation of a parabola. So we talked a little bit about parabolas in Chapter 1, the general format for the standard equation of a parabola is y equals x squared. Now, if we shift this parabola to the right and up or down or to the left or any of those things, that's going to change this equation. And we talked about some of the ways that the equation would be changed, right? If we move it right or left, then you'll have that shift indicated inside the parentheses where the x is. So let's say we're going to put this vertex for the parabola at the new point where x is h and y is k. So that means we've shifted it over to the right h places. So now the equation will be y equals x minus h all squared. And then we've pushed it up k places. And so we could put a plus k on there. So that's some of what can happen here. The other thing that can happen is if we put a coefficient in front of the x, if that coefficient is less than 1, then it'll open up the parabola like this. This would be like y equals 0.1x squared. And if you make that coefficient bigger than 1, then you get these really skinny parabolas that grow, the y values grow very quickly. Okay? All right, so that's sort of an introduction here. And the parabola is really useful. There are a lot of quantities that have parabolic relationships. My favorite one is time versus distance. When you drop something, right, acceleration due to gravity is a quadratic relationship. It's not a linear relationship. It's not proportional to the number of seconds it's been falling. It's proportional to the square of the number of seconds it's been falling. Let's see, 9 times 16. Yeah, and so the equation here is that d is 16t squared. And that's why when you throw something through the air, as gravity acts on it, it pulls it down into the shape of a parabola until it comes back to the ground. Okay, this is a parabolic shape. Okay, let's see here. So we're going to have a standard equation for the parabola. Let me talk about where that equation comes from. So instead of starting out with the standard, that y equals x squared, I'm going to start out, let me make a bigger picture here. I'm going to start out with a parabola with a vertex at the point hk. You've got a parabola kind of doing this. And this is similar to how the Greeks defined this again. Okay? So, from the Greek definition for the parabola, it's the locus of points, or the collection of points, equidistant from a given point and a given line. Okay? And so let's draw the point and the line first. Then that would put the vertex halfway between them, and these two sides would go up like this, so that this distance and this distance end up being the same thing. Okay? So let's see here. I'm going to follow what I've done in the textbook. And so this thing down here is called the directrix. Okay, and let's see, so this is the point hk. And this thing right here is called the focal distance, that distance right here. And we use the letter P to describe that. Okay, this point up here is called the focus. And let's see here, this would be the point, x is still going to be h, but then the y is going to be k plus p. Down here, all right, this is the focus, this point right here. Down here we have the directrix. This is a line, so it's a horizontal line in the form y equals. and in this case it'll be y equals k minus b. Okay? Alright, let's see here. Now, before I move on, I just want to say something else about applications. We'll look at some more of these later in the textbook in Chapter 2. If you take a parabola like this and you rotate it in 3 dimensions, you get this shape that's called a paraboloid. And this has some very interesting properties. You might see these on the sidelines of a televised football game. They use what's called a parabolic microphone, so that all the sound that comes in is amplified. It's sort of a natural amplifier. People also use this as a solar cooker. You put the food at the focus, and then the sun's rays as they come in. So this is the feature of the paraboloid shape. And you can do this with the parabola as well. Anything that comes into the parabola is immediately reflected to the focus. Okay? And so, I don't know if you've ever looked at the cover picture for the textbook that we're using. This is an application of this concept to generate solar power. Okay? The picture that I've got there is what's called the tower scenario, and you surround the tower with these banked mirrors in the shape of a paraboloid, okay? And the tower is at the focus, okay, of that paraboloid. So, as the sun is shining on all these mirrors, it's reflecting the heat from the sun to this tower. They put salt in that tower, and it gets so hot, like 500 degrees Celsius, it melts the salt. And then once it becomes liquid, it flows out of the tower and into a holding tank. They typically use a holding tank. You can generate electricity directly during the daytime, but a lot of what they do is they store it so that when nighttime comes around, you can take it out of the insulated tank. And the whole thing operates on a steam, essentially a steam engine idea, where you use the you run the molten salt through pipes in a water tank, turns that water to steam. The steam helps you to generate electricity. They've got a couple of these built down in California right now. They're like 300 megawatt systems. A typical coal-fired plant is usually about 500 megawatts. A lot of those dams, the big dams, those can be 1,000 megawatts. Those produce a lot of electricity, and they do it very cheaply. That's part of the reason why Boeing located itself out here in the Pacific Northwest, is because there was a lot of cheap hydropower at the time of World War II. Okay, so enough with the applications. We'll talk about that when we get to that section in the textbook. Okay, but there is this thing where anything that comes into a parabola and hits the side of it gets reflected to the focus. Now, they do that, the opposite of that with flashlights too. You put the light of the flashlight at the focus of the paraboloid, and so then it shines out, but then anything that's not shining out gets reflected out. Okay? And so that's the opposite thing. You've got the light at the focus, and so that it creates this beam of light because of the reflection properties of the paraboloid. Okay. Let's see. So remember the definition of the points on the parabola, and we'll call these x, y, is that they are equidistant from this point and this line. All right? So we're going to use the distance formula, and that's going to allow us to generate the general equation for a parabola. Okay. The distance between these 2 points, we're going to use the distance formula. Square root of x minus h all squared plus y minus parentheses k plus p all squared. So there's that distance right there. Okay? This distance right here, this is a vertical distance. We don't need the distance formula. It's just the difference between this value of y and this value of y. Y minus k minus p in parentheses. And that's it. That's all we have to worry about. Okay? All right. So now we have to square both sides so that we get rid of this square root piece, right? Okay. So that'll bring this out from under the square root, x minus h all squared, y minus k plus p all squared. Now we've got to square this. Y squared minus 2k minus p plus k minus p all squared. Okay. Let's see. Okay. This x minus h squared is going to be in our final equation, so I'm going to leave that alone, but I'm going to expand this similar to the way that I expanded that. So x minus h all squared plus y squared minus 2 times k plus p plus k plus p all squared. All right, so first off, I'm going to subtract y squared on both sides. Okay, so those two are going to cancel each other out. I'm going to expand these and collect like terms. All right, let's see. Oh, I'm going so fast. You know what I did? When I expanded this, here, let me write it down for you. You may have seen this mistake already. So there's the y squared. And then minus y times k minus p here, and then another minus y times k minus p there. And so this 2 should actually be a 2y k minus p. Okay? And we're going to need that here as well. There we go. And I did the same thing over here. Okay? When I'm squaring this out, it's not just going to be minus 2k plus p. It's minus 2 times y, k plus p. All right. Now let's distribute and look for like terms. So x minus h all squared minus 2yk minus 2yp plus k squared 2kp plus p squared. Okay. Do the same thing over here. Minus 2yk plus 2yp plus k squared minus 2kp plus p squared. All right, now we've got some really nice cancellations here. Plus 2yk plus 2yk. Minus k squared minus k squared. Minus p squared minus p squared. That all cancels out. All right, now what? X minus h all squared minus 2yp plus 2kp equals 2yp minus 2kp. All right, so I'm going to move these things over to this side. Plus 2yp minus 2kp plus 2yp minus 2kp. Those cancel each other out. And so we get x minus h all squared equals 4py minus 4pk. So let's factor out the 4p, y minus k, x minus h all squared. That's the standard equation for a parabola. Okay? All right. I'm going to leave that picture up. I'm going to erase this. This is in the textbook. We've also just made a video of it. So you can rewind if you want to see that. If you want to see me make that mistake again. Okay. So here's the standard equation. And this is for an upward facing parabola. Is that we get this, I'll make some room here. X minus h all squared equals 4p times y minus k. So hk, hk is the vertex, p is that focal distance, okay? All right, now, if the parabola is flipped upside down, like this, that means the directrix is back here, and the focus is now right there, okay? And what that means is that this p-value, right, if this is k plus p in this scenario, for that to work out here, that says that p is going to be negative. Okay? If we call this h and k plus p, that still works if p is negative. Same thing up here. This will be y equals k minus p. When you subtract this negative value, that'll make it bigger. So, what that does is that makes this value a negative. All right? Now, let me say something about standard equations. If you look at 5 different textbooks that talk about parabolas, you'll probably see 3 or 4 different standard equations. And I make those air quotes because the word standard is supposed to imply, well, this is the way everybody does it every time. It doesn't, okay? It's just for every textbook, they're going to choose their standard equation. The one that I've chosen for our textbook is this one right here, okay? Now, there is some, I can create confusion in talking about the parabola this way, in that here, for an upside down parabola, I'm going to put the negative sign in there. And that means that this value for p will technically be positive, but if you put the negative sign here, that means that it will be flipped upside down. Okay? And so whether you decide to include, I like to include the negative sign here because it reminds people, oh, that's flipped upside down. Okay? So if you get a p-value that's negative, generally that's going to be an upside down parabola. Now, if we turn this parabola on its side, like this, now your parabola is, your vertex is here at hk, you've got your focus here, but the trick for that is that now the focus is shifted to the right. See here, the focus changed the y coordinate, but on this one, the x coordinate is going to be h plus p, and the y coordinate is still going to be k. And the directrix is going to be a vertical line with the equation x equals h minus p. Okay? And that's going to make this equation, I'll do it the same that I did in the textbook. Yeah. Y minus k all squared equals 4p times x minus h. That is opens to the right. If it opens to the left, it'll be the opposite. Y minus k all squared is negative 4p times x minus h. And this is something that you'll see on the quizzes. I will try to include them in the quiz. If I don't, feel free to look it up while you're doing it. I do put this on the final exam. You've got those standard equations to work from. You don't have to memorize them, is what I'm saying. Okay, so let's look at a couple problems. Now this section is split into 2 pieces. I'm only going to cover this first part of section 2.2 in this video. Okay, so let's look at an example problem, and then we'll look at the exercises on pages 88 and 89, and then we'll save the next set of exercises for another video. Okay, on page 87, we've got this example. It says, given the following information, determine equation for the parabola. Focus is the point 32. Vertex is the point 12. Okay, so 3, 2, vertex is 1, 2. So, if the vertex is here, right, remember how these go. focus is always inside of the parabola. Okay? That means this parabola is going to open up to the right. Okay. So, given that information, let's see, this is the point 3, 2. This is the point 1, 2. That means our focal distance, P, has got to be equal to 2, the difference between 3 and 1. Okay? So there's our focal distance. That means the directrix is back here at x equals -1. Now, the problem isn't really asking us for that. What is the problem asking us? Determine an equation. All right. Well, this is a rightward-facing parabola. That means our equation is going to be in that format. Y minus k all squared equals 4p times x minus h. All right, we've got the vertex. It's the point 1, 2. There we go. The value of p is 2. And there's our equation. Y minus 2 all squared equals 8 times x minus 1. Okay. All right, let's look at the problems in the section there. I think it's pages 88 and 89. All right, problem 2. We've got a focus at -4, 3 and a vertex at -3, 3. All right, so 1, 2, 3, 4, 2, 3. So there's our focus, -3, 3 is the vertex. Okay, so remember the focus is always inside the parabola. That means this parabola is opening up to the left. That's going to match it up with this one right here. Y minus k equals -4p x minus h. Well, we already know h and k because we know the vertex, right? So the x coordinate, x minus -3, x plus 3. Over here, oops, we'll get y minus 3 squared. And now we just need to know the value of p. What's the focal distance here? That distance is 1. Okay? If you want to think of it as -1 because it's going to the left, that's what this negative sign right here represents. All right? So, -4 times 1, x plus 3 equals y minus 3 all squared. And there we go. All right. Let's keep going with these. Problem 4. Focus, -9, 0. Vertex, -9, -1/2. Okay, so on a graph, let's see, -9, 0 is the focus, -9, -1/2 is the vertex. So, if this one is the focus, that one is the vertex, that means the parabola is opening up like that. And if that's the case, that means our standard equation is going to be that first one that we talked about. X minus h all squared, 4p times y minus k. And let's see, our vertex, the x coordinate's -9. So we do x plus 9. The y coordinate's -1/2. So this will be y plus 1/2. And what's that focal distance? The difference between this y value and that y value is 1/2. 1/2 times 4 is 2. Y plus 1/2 equals x plus 9 all squared. All right, let's see here. Problem 6. So this one's a little bit different. Here we've got a focus at at 0, 3, and the directrix is the line y equals 1. Now that's the only information that we get. So, y equals 1 is here. 0, 3, we'll put it up there. That's the focus. So that means the vertex is halfway between them. Okay? Halfway between 1 and 3 is 2. That's our vertex. 0, 2 is the vertex. With the focus inside the parabola, that says the parabola is opening up. So we're using our standard equation. X minus h squared is 4p times y minus k. Now we know the vertex. Okay? Remember, the vertex is always halfway between the directrix and the focus. All you really have to do, if you're not sure, is to take these y values and average them. 3 plus 1 divided by 2 is 2. The x-coordinate will be the same as the x-coordinate for the focus. So, this will be x minus 0 all squared, and this will be y minus 2. And then the question of, well, what's the value of p? What is that focal distance? 1, right? Distance of 1 from here to here, distance of 1 from here to here. This right here was a distance of 2. That's how we found the vertex. So, this will be x squared equals 4 times y minus 2, and there we go. Okay, let's keep going with these. Now we've got another one of these focus and directrix problems, number 8. Let's see, the focus is negative 4, 8, and the directrix is the line y equals negative 6. Okay. So let's make a little sketch here so we can see what's happening. Negative 4, positive 8, that's our focus. And x equals negative 6 is going to be out here. Okay? So remember, the vertex is going to be halfway between them. So that's going to put our vertex right there, right? This is x equals negative 6. That means that vertex is going to be right there where x is the, yeah, you probably can't really see that from the camera. The vertex is where x is negative 5, and the y is going to be the same as the y coordinate for the focus, which in this case is 8. So that's our vertex, negative 5, 8. And with the focus inside the parabola, that means the parabola is facing off to the right, which means that we're going to use this equation, y minus k all squared equals 4p times x minus h. Put the coordinates for the vertex in there, x minus negative 5, so x plus 5, and then the other one will be y minus 8 all squared. And then the last thing we can do, what's the focal distance here? Just 1 on either side, right? So this is just going to be 4 times 1, x plus 5, y minus 8 all squared. There we go for number 8. Okay, let's see here. Problem 10, that's a little bit different. So every parabola has what's called an axis of symmetry. Right? Splits the parabola in half. And if the axis of symmetry is parallel to the y-axis, then that means the parabola is either facing up or down. If the axis of symmetry is parallel to the x-axis, that means the parabola faces right or left. So, problem 10, we've got a vertex at the point 4, 2. Axis of symmetry parallel to the y-axis. So that means it's either going to face up or face down. Let's see, I'll fill that in a sec. And contains the point 5, 0. So let's make a graph here. Let's stop guessing put some coordinate axes up there. 4, 2 is right there. Also contains the point 5, 0 with an axis of symmetry parallel to the y-axis. So now it's starting to take shape. Okay? So it's either got to point up or point down. It can't point up if this is on the curve, right? So that means it must be pointing down. Okay. What else? Now we know that this is 4, 2. We know that that's 5, 0. This is the equation we want right here. X minus h all squared, negative 4p y minus k. We'll put in our vertex coordinates, y minus 2. Okay, so now we need to find out what the value of p is. But we don't know the focus, we don't know the directrix, so we don't have a value for p. And that's how we've been doing that, is just getting that value for p from the graph. So what we have to do this time, I was actually just doing the equation of a line with mass 70. And if you remember, once you find the slope of a line, the way to find the y-intercept is to plug in one of the points that you know for the x and y values. So, x is 5, y is 0. So, here's 1 squared equals negative 4p times negative 2. That says 8p is 1, p is 1/8. Okay, so now we can go and put this back in here. 4 times an 1/8 is a half. Negative 1/2 y minus 2 equals x minus 4 all squared. And there's the equation for that parabola. All right, let's see here. I'll do one more of these. Problem 16 is similar to this problem. Okay, so problem 16, we've got a vertex at the point negative 6, negative 6. So there it is. What else? Axis of symmetry parallel to the y-axis. Okay, so that means, oh, that's not where I want to put that. Here we go. Axis of symmetry parallel to the y-axis. That means it's either going to be up or down. Contains the point 0, 0. That says it must be facing up. Okay? So, if it's facing up, this is the equation we want. X minus h all squared, 4p times y minus k. This is 0, 0. So now let's fill in our coordinates for the vertex. So this will be x plus 6 all squared, 4p, y plus 6. And now we plug in the 0, 0, and we can find a value for p. So this one is 6 squared, 4p times 6, 36 is 24p, and p is 3 over 2, or 1.5, right? Divide on both sides by 24, and you'll get 1.5 for the value of p. So now we go back and plug it in here. X plus 6 all squared. 4 times 1.5 is 6. Y plus 6. And there we go. Okay, so that's a good start on this equation of a parabola section. Like I said, we've got another set of exercises, and I will make a separate video for those. If you have any questions, please let me know. Thanks.